What would happen if every nuclear weapon on Earth detonated simultaneously? Not just one bomb, not just a limited exchange, but all of them, right now. The answer is more catastrophic than most people can comprehend. As of 2024, there are approximately 12,500 nuclear warheads on our planet, with around 9,500 actually deployed or ready for use. These aren't historical weapons. Modern nuclear arsenals are exponentially more destructive than anything seen before. Together, the world's nuclear arsenal packs a combined explosive yield of about 6,000 to 7,000 megatons of TNT. To put this in perspective, if we converted this explosive power into standard cargo ships filled with TNT, it would require over 6 million ships. Lined up, end to end, they would circle the entire Earth. Or imagine this, if we detonated just 1 metric ton of TNT every second, it would take over 190 years to equal the explosive power in today's nuclear arsenals. That's enough explosive force to simultaneously destroy every major city on the planet many times over. These weapons range from smaller tactical nukes of 10 to 100 kilotons, designed for battlefield use, to strategic city killers with yields of 300 to 800 kilotons, each one capable of obliterating everything within miles of detonation. And then there are the monsters. Russia's RS-28 Sarmat missile carries multiple warheads with a combined yield of up to 50 megatons, comparable to the Tsar Bomba, the largest nuclear device ever tested. The Tsar Bomba's mushroom cloud reached nearly 40 miles into the atmosphere, 4 times the height of Mount Everest. Its shockwave circled the Earth 3 times. But what would actually happen if every single one of these weapons detonated? The reality is far worse than most apocalyptic movies portray. Before we explore that nightmare scenario, if you're finding this terrifying but fascinating, hit that subscribe button and like this video. Only a tiny percentage of viewers actually subscribe, and it helps us create more content like this. The real question isn't just about the explosions themselves. It's about what comes after. And that's where things get truly frightening. Now that we understand the sheer destructive power contained in the world's nuclear arsenals, let's examine what scientific models actually predict would happen in this scenario. Despite what science fiction often portrays, the Earth as a planetary body would survive this catastrophe. But while our planet would continue orbiting the Sun, life on Earth would face an unprecedented catastrophe that goes far beyond the initial explosions. The most severe long-term threat comes from what scientists call nuclear winter. When cities burn, they release something more dangerous than radiation for global survival: soot. Computer models from leading climate scientists predict between 150 and 180 million tons of black carbon would be injected into the stratosphere. Unlike rain clouds, these particles wouldn't wash out. They'd remain suspended for years, blocking approximately 70% of sunlight from reaching Earth's surface. The resulting temperature drop of 26 degrees globally doesn't sound extreme until you realize what it means for agriculture. Farming regions across North America, Europe, and Asia would lose entire growing seasons. Global food production would collapse within months. Another factor most people overlook: electromagnetic pulse effects. High-altitude nuclear detonations produce EMPs that could instantly disable electronics across entire continents. Power grids, communications, transportation, all gone in microseconds. The models are clear. While the immediate blast would kill hundreds of millions, the secondary effects would claim billions more lives within 2 years. What's perhaps most chilling about these simulations is that they're based on peer-reviewed science, not speculation. Before we explore what the aftermath would look like for survivors, take a second to subscribe if you want to understand the threats our world faces. Now let's examine what would happen in the critical first hours after detonation. In a nuclear exchange, the weapons wouldn't simply appear over targets. They'd be delivered through sophisticated systems, designed for maximum speed and survivability. Intercontinental ballistic missiles, or ICBMs, represent the backbone of nuclear arsenals. These are housed in hardened underground silos, designed to withstand everything except a direct nuclear hit. Russian Topol-M mobile launchers add another dimension. These truck-mounted missiles can hide in forests or mountains, making them nearly impossible to target preemptively. But the most survivable delivery systems lurk beneath the ocean surface. Nuclear submarines can remain hidden for months, carrying enough firepower to devastate entire countries. The Ohio-class submarine alone carries up to 20 missiles, each with multiple warheads. This creates what strategists call second strike capability. Even if a country's homeland is completely destroyed, their submarines can still launch a devastating counterattack. In the air, strategic bombers like America's B-2 Spirit and Russia's Tu-160 can deliver nuclear gravity bombs or cruise missiles from standoff distances. What's truly terrifying is the timeline. Early warning satellites equipped with infrared sensors would detect missile launches within seconds. But then the clock starts ticking. From launch to impact, targets have between 5 and 30 minutes before detonation. For cities near submarine launch areas, that window could be as little as 5 minutes, barely enough time to comprehend what's happening, let alone evacuate. For targets across oceans, the flight time extends to about 30 minutes. Still hardly enough time for meaningful evacuation of major population centers. Think about that. The time between detection and destruction is less than an episode of your favorite TV show. If you're finding this information valuable but disturbing, that's exactly why understanding these systems matters. Hit subscribe to learn more about the technologies that shape our world's security landscape. In our next section, we'll see exactly what happens when these weapons reach their targets. Blast effects in major cities. Let's focus on what happens when a single modern nuclear warhead, an 800-kiloton Russian RS-24 warhead, detonates over Manhattan. The first effect is the fireball, a sphere of plasma hotter than the surface of the sun, expanding to 2 to 3 kilometers in diameter within seconds. Everything from Central Park to the Empire State Building isn't just destroyed. It's vaporized, turned instantly to gas and elemental particles. But the destruction extends far beyond Midtown. The thermal radiation, heat and light so intense it ignites everything flammable, extends outward at the speed of light. Up to 10 kilometers from ground zero, reaching into Brooklyn, Queens, and the Bronx, exposed skin suffers third-degree burns, clothing ignites, all of Central Park becomes an inferno. And then comes the shockwave. Moving at supersonic speeds initially, this wall of overpressure flattens reinforced skyscrapers in lower Manhattan and shatters windows as far as Newark and Yonkers 20 kilometers away. Now imagine this happening not just in New York, but simultaneously in every major capital worldwide. Paris. The Eiffel Tower warps and collapses as the 7th arrondissement is vaporized. London. The Houses of Parliament and Buckingham Palace disappear in the fireball. Moscow. The Kremlin and Red Square are obliterated. Beijing. The Forbidden City and financial district become a crater. The consequence, the global internet would collapse as the largest data centers are destroyed. Google's server farms in Virginia, Amazon's in Oregon, the major European hubs in Frankfurt. Undersea cables connecting continents are severed at their landing stations. The financial system would cease to function as the New York Stock Exchange, London's financial district, and Tokyo's trading centers vanish simultaneously. Healthcare networks would be overwhelmed instantly. Major research hospitals like Massachusetts General, Johns Hopkins, and London's Royal Free Hospital would be gone, along with their specialized equipment and irreplaceable medical expertise. Within 24 hours, The interconnected systems that define modern civilization would be gone. What's perhaps most terrifying is that we're still only discussing the immediate effects. Have you ever wondered how you would react in these first crucial moments? Let us know in the comments. But the truly devastating consequences are just beginning to unfold. Fallout and the days after. The initial blasts would be just the beginning. Within hours, an invisible killer begins spreading across continents. Nuclear fallout, radioactive particles carried by the wind, would begin descending from the mushroom clouds, contaminating everything they touch. Using atmospheric dispersal models, scientists have mapped how these deadly particles would travel. The results are chilling. From a detonation over Washington, D.C., the fallout plume would stretch hundreds of kilometers, potentially reaching as far as Boston or Charlotte, depending on wind conditions. Similar patterns would emerge worldwide. Within 48 hours, most of Europe, Western Russia, Eastern and Central United States, and Eastern China would be blanketed in radioactive dust. This isn't just dirty air. Fallout contains specific radioactive isotopes with devastating health effects. Cesium-137, with a half-life of 30 years, contaminates soil and enters the food chain. Iodine-131 attacks the thyroid gland, causing cancer and endocrine disorders. Perhaps most insidious is strontium-90, which the body mistakes for calcium. It gets incorporated into bones and teeth, irradiating people from within for decades. Anyone caught in fallout zones without shelter would face acute radiation syndrome, vomiting, hemorrhaging, and potential death within days. Those who survive the initial radiation would face dramatically increased cancer risks for the rest of their lives. The soil itself would become poisoned. Agricultural regions downwind from major targets would be unable to safely grow food for years or even decades. Water supplies would be contaminated as radioactive particles wash into rivers, lakes, and eventually oceans, spreading the contamination even further. What makes fallout particularly terrifying is its invisibility. You can't see, smell, or taste it. Yet exposure for just minutes in heavy fallout zones can deliver lethal doses. The only protection? Getting inside buildings with thick walls and staying there, potentially for weeks. Would you know what to do? How long to shelter? When it's safe to come out? And remember, this is happening in a world where communication systems, emergency services, and government guidance have largely collapsed. But even as the fallout begins to settle, an even larger threat looms on the horizon. Climate aftermath. Nuclear winter. The most devastating consequence of global nuclear war wouldn't be the explosions or even the radiation. It would be what happens to our planet's climate. This isn't science fiction or speculation. NASA and multiple peer-reviewed studies, including landmark research by Robach and colleagues in 2007, have confirmed the chilling reality of what scientists call nuclear winter. Here's how it happens. When cities burn after nuclear strikes, they release massive amounts of black carbon soot into the atmosphere. Unlike normal smoke, this fine particulate matter rises into the stratosphere above weather patterns that would normally clear the air. Once in the stratosphere, these particles spread globally within weeks, forming a shroud around the Earth. The effect? Sunlight blockage on a scale that would transform our planet. Measurements indicate sunlight would be reduced by 70 to 90% in many regions. Imagine perpetual twilight, day after day, for years. Without sunlight, global temperatures plummet. Average surface temperatures would drop by 5 to 10 degrees Celsius, 9 to 18 degrees Fahrenheit, in continental interiors within weeks. This isn't just a bit colder. For comparison, the difference between our current climate and the last ice age was about 5 degrees Celsius. Global rainfall patterns would collapse. The Asian monsoon, which billions of people depend on for agriculture, would fail completely. Even the oceans would change. As carbon dioxide from the fires dissolves into seawater, oceans would acidify, devastating marine food chains. The result? Global famine would begin within months. Photosynthesis would slow dramatically or stop in many regions. Crops would fail across entire continents. Global food production could drop by over 90%. Even in regions spared from direct nuclear effects, food supplies would dwindle within weeks. Global food reserves would be exhausted within months. This isn't alarmism, it's physics and climate science. Models have been refined over decades and consistently show the same devastating outcome. In fact, researchers believe even a limited nuclear exchange could trigger these effects. A full-scale war using all arsenals would create conditions unlike anything humans have experienced in recorded history. The most terrifying aspect? Unlike the bombs themselves, there would be nowhere on Earth to hide from these climate effects. If you're finding this information valuable but disturbing, hit subscribe. Understanding existential risks is the first step toward addressing them. But what about survivors? Is there any hope for those who might live through the initial catastrophe? Mutual assured destruction response. What makes nuclear war particularly devastating is not just the power of individual weapons, but the strategic doctrine that governs their use. Welcome to the chilling logic of mutual assured destruction, aptly abbreviated as MAD. The concept is brutally simple. Any nuclear attack will trigger an overwhelming response, ensuring that the aggressor is also destroyed. This isn't theoretical. It's built into the command systems of every nuclear power. Both the United States and Russia maintain what's called launch on warning capability. Their missiles can be launched within minutes of detecting an incoming attack, even before enemy warheads arrive. This creates a hair-trigger situation where decisions must be made in minutes, sometimes seconds. If Russia launched against a NATO country, Article 5 would be invoked instantly. An attack on one member is considered an attack on all. This would trigger immediate nuclear responses from not just the United States, but also Britain and France, both independent nuclear powers within NATO. China maintains a no-first-use policy, but has built increasingly sophisticated second-strike capabilities to ensure retaliation against anyone who attacks them. India follows a similar doctrine, with nuclear submarines and mobile launchers designed specifically to survive a first strike and ensure retaliation. What this means in practice is terrifying. Once a single nuclear weapon is launched against a major power, a chain reaction begins that is nearly impossible to stop. Based on known strategic protocols and missile flight times, experts estimate that a full exchange involving all nuclear powers could unfold in under 60 minutes. One hour. That's all it would take to end modern civilization. Military planners call this use it or lose it pressure, the knowledge that any hesitation means your weapons might be destroyed before they can be launched. This creates enormous pressure to escalate quickly and massively once nuclear weapons enter the equation. Even more disturbing, some nuclear powers have systems designed to launch automatically if their command centers are destroyed. Russia's rumored dead hand system, for example, is designed to detect nuclear detonations on Russian soil and launch a full counterstrike automatically if Moscow goes silent. The cold logic of MAD has prevented nuclear war so far, but it also guarantees that if deterrence ever fails, the conflict won't remain limited. Before we continue to the final part of our analysis, ask yourself, should the fate of civilization rest on systems designed to react within minutes? Let's examine the ultimate question. Would anyone survive this scenario at all? Speculative but grounded possibilities. Now we enter territory where expert opinions diverge. Scenarios that are speculative but grounded in known capabilities and physics. Let's start with something most military analysts consider real but classified. Failed deadly systems. Russia's perimeter system, sometimes called Dead Hand in the West, represents perhaps the most unsettling, fail-deadly mechanism ever created. Unlike normal command structures, perimeters designed to function after leadership has been eliminated. If it detects nuclear detonations on Russian soil and cannot contact Moscow, it can allegedly launch automatically. This means even a successful first strike that eliminated Russian leadership would still trigger full retaliation. While experts debate the exact details, similar systems may exist in other nuclear states, ensuring that no attacker could win by decapitating enemy leadership. Even more concerning is the scenario where all nuclear weapons detonate simultaneously. While not probable through conventional means, experts worry about scenarios involving cyber attacks on nuclear command systems or artificial intelligence errors that could bypass normal command chains. Former Defense Secretary William Perry has warned about exactly this scenario, where false alerts or compromised systems could trigger launches outside normal doctrine control. Such a synchronized attack would eliminate the possibility of recall or stand-down orders, as decision-makers would be eliminated before they could countermand automated responses. Moving from military to environmental speculation, what about planetary effects? Despite what some science fiction suggests, Earth would not crack or be knocked from its orbit. The combined nuclear arsenal, while devastating to life, represents a tiny fraction of the energy needed to affect planetary orbit. However, more subtle geological effects are possible. Multiple simultaneous nuclear explosions along geological fault lines could potentially trigger earthquakes in already unstable regions. Volcanic systems near detonation points might be affected as well. The massive pressure changes could potentially trigger eruptions in volcanoes that are already close to erupting. The electromagnetic effects of high-altitude nuclear detonations could temporarily disrupt Earth's magnetic field, creating unpredictable effects on everything from animal migration to electronic systems that might have somehow survived the initial EMP. While these effects would be secondary to the immediate destruction and nuclear winter, they represent additional unknowns in an already catastrophic scenario. Perhaps most chilling is what we don't know. The unforeseen consequences when multiple catastrophic systems interact in ways never before witnessed. If you've stayed with us this far, you clearly care about understanding the world's most dangerous weapons. Subscribe to support more in-depth analysis of the forces shaping our future. Now, the question we've been building toward: would humanity survive? To truly understand what nuclear war would mean, we need to step away from statistics and simulations and consider the human experience. Imagine you're driving to work on an ordinary Tuesday morning. Traffic is heavy but moving. Your coffee sits in the cup holder. The news is playing something about international tensions, but you're thinking about your meeting at 9:30. Without warning, a blinding light fills your vision, so bright it penetrates your closed eyelids. For a moment, you think someone has taken a photo with an impossibly powerful flash. As your vision fills with after images, you hear cars crashing around you. Drivers, blinded simultaneously, are swerving and colliding. Then, approximately 30 seconds after the flash, depending on your distance from ground zero, it hits. The shockwave arrives like a physical wall. Your car windows implode, sending glass shards flying. The vehicle itself is picked up and tossed like a toy. The last thing you hear is the deafening roar of a hurricane-force wind carrying debris from shattered buildings. Now, a different scenario. You're on a metro train, deep underground. During rush hour, the car is packed with commuters staring at phones or reading. The lights flicker violently, then go out completely. The train lurches to an emergency stop, throwing passengers against each other. Emergency lighting provides minimal visibility. Ventilation systems have stopped. There's no announcement. The entire electrical grid above has been knocked out by electromagnetic pulse. Minutes pass. The air grows stale. Panic begins to build as no information comes through. Some people try calling emergency services, but phones show no signal. What passengers don't yet realize, the city above them has been devastated. The infrastructure to rescue them may no longer exist. The tunnels themselves might become their tomb as oxygen depletes, or worse if they collapse from nearby detonations. Finally, consider being on a commercial flight. You're cruising at 35,000 feet. The flight attendant has just served drinks. Below, clouds obscure the landscape. Suddenly, multiple bright flashes appear on the horizon. Even at this altitude, they're blindingly bright. Passengers begin pointing and questioning. In the cockpit, chaos erupts. Communication systems go dead. Navigation equipment fails as ground-based systems are destroyed. The electromagnetic pulse from high-altitude detonations affects aircraft electronics. The aircraft encounters severe turbulence as shockwaves propagate through the atmosphere. Power fluctuations cause cabin pressure issues. Oxygen masks deploy. As the plane banks sharply, searching for a place to land, passengers witness the unthinkable. Multiple mushroom clouds forming over what were cities just moments ago. With air traffic control gone and many airports destroyed, pilots face impossible decisions about where to attempt landing, with limited fuel and compromised navigation. These are just 3 scenarios among billions of individual tragedies that would unfold simultaneously. In each case, ordinary people with no warning would find their lives transformed or ended in moments. The most haunting aspect, these wouldn't be movie characters or statistics. They would be us. How do you react in those crucial first moments? Could anyone truly be prepared? We've walked through the unthinkable, a scenario that represents humanity's darkest possibility. The science is clear. If every nuclear weapon on Earth were detonated, civilization as we know it would end. Yet this nightmare scenario remains just that, a possibility, not an inevitability. Throughout the Cold War and beyond, we've come terrifyingly close to nuclear conflict multiple times. Yet, each time, individual human decisions prevented catastrophe. The very fact that you can watch this video means we've collectively avoided this fate so far. The question is whether we can continue to do so indefinitely. Nuclear weapons exist in a paradox. Created to prevent war through deterrence, yet posing an existential threat to humanity's survival. Understanding. If you found this analysis valuable, there are 3 things you can do right now. First, subscribe to our channel. We're dedicated to explaining complex global systems that shape our world, and your subscription directly supports this work. Second, hit that notification bell. Our next video will explore the technologies and treaties that have successfully reduced nuclear arsenals over the decades. Finally, join the conversation below. What aspect of this scenario surprised you most? What questions do you still have about nuclear weapons and their effects? Knowledge is the first defense against catastrophe. By understanding these weapons and their consequences, we contribute to the pressure that keeps them locked away, never to be used. Thank you for taking this journey with us. Until next time, stay curious and hopeful.